Hello, and welcome everyone to today's webinar on Delegated Connection Design in Industrial Pipe Rack Structures. My name is Stephanie Kennard. I'm the CEO of IDEA StatiCa US, and I am excited to be hosting you for today's discussion. A little bit of housekeeping before we begin. As an audience member, you should see your GoToWebinar control panel typically on the right-hand side of your screen. Everyone will stay muted during the presentation and recorded portions, but after the demo, you'll be able to unmute yourself and ask any questions. Alternatively, you can always type your question into the questions panel. We'll answer as many as possible live, and if there are any we don't get to, we will follow up afterwards. For those of you that are new here, we always like to start by introducing the breadth of IDEA StatiCa's analysis and design capabilities across both steel and concrete structures. Starting with steel, our connection application allows engineers to design and verify even the most complex joints. From bolted to welded configurations, this is ideal for moment connections, base plates, and even complex joints with irregular geometry. Next, we look at steel members, allowing you to go beyond simple beam calculations, enabling analysis of buckling, stability, and interaction effects under various load combinations. This gives engineers confidence in their designs, especially for non-standard cases. Detail is focused on the local zones of a concrete structure. We're talking about areas like corbels, frame corners, deep beams, or regions around large openings, places where stress flow becomes nonlinear and simple hand calculations or spreadsheet checks just don't give us the full picture. And finally, we have composite scenarios, steel and concrete working together. IDEA StatiCa enables integrated analysis of hybrid connections and details, which is especially valuable in anchoring design, retrofit projects, and complex industrial structures. Now, before we dive into the details of delegated design, we'd love to hear from you. Delegated design is a topic that's come up again as we meet with engineers, so let's start with a quick poll. If you're involved in delegated connection design, what's the biggest communication challenge you face? And if delegated connection design is new to you, we still invite you to take a guess as to what you think the biggest communication challenge may be. All right, I'm going to close this and share the results. And you can see we have a clear winner. 35% are saying getting the design load information is the biggest challenge. Now, regardless of your choice, I think all of these options lead us to the biggest challenge of all, which can be that everyone believes they're designing the same structures, but we're actually working with different assumptions. Now, Corbin and I will touch on some of these challenges during this discussion, so let's go ahead and dive in.
Hello, everyone, and welcome. My name is Stephanie Kennard, and I am the CEO of IDEA StatiCa US. Thank you for joining us today. Today is a special session for us. This is our final webinar of 2025, and we are reflecting on the productive year we have had and looking ahead to an even more exciting 2026. The past year has been all about expanding capabilities, empowering engineers, and accelerating connection design workflows. Some highlights include the release of IDEA StatiCa version 25, which introduced new anchoring and baseplate design features, which aligned with ACI and AISC standards. Expanded integration with CheckBot, streamlining bulk analysis for large projects. And perhaps most importantly, the incredible feedback and collaboration we've experienced from engineers like all of you. Your support continues to help us refine and improve the tools we create that help power your daily work. As we look ahead to 2026, our focus remains the same, helping engineers design faster, safer, and smarter. Today's session is a great example of that mission in action as we have a special guest. Corbin Collier of Weldment Design is joining us to share some of his learned experiences in industrial delegated design. Now, if you've joined our webinars before, you may recognize Andrea Castello. Andrea is of our very own IDEA StatiCa, and she'll walk us through some of IDEA StatiCa's time-saving features that might help you with your next connection design project. So let's get started. Corbin, thank you for joining me today. It is so great to have you here with us. Now, some of our viewers may not be familiar with you and your company. So could you start by telling us a little bit about your background and your work at Weldment Design?
Thank you, Stephanie. Yes, so I started out in the steel industry due to my family's company. They had a steel fabrication company that was created back in 1962, actually sold in 2023. But I started off as a fabrication apprentice, which kind of gave me, I think, my slightly different approach into engineering. My father was the one who was in charge of all fabrication and heavy moves, and so they would be moving these multi-million pound barges and large steel structures, and I was really just amazed by this. I wanted to understand really how it was done, and so that really pushed me into engineering, and followed the classical approach. I actually had a mechanical engineering degree initially, and then got my PE in 2018, created Weldment Design in 2019. Since then, our main focus really has been supporting fabricators, just like what my family's company was. I saw some of the headaches that they had in fabrication, and I wanted, to be the engineer to kind of help fix that. So ultimately, my goal has been to provide outsourced engineering services to these fabrication companies to really help them achieve the goals that they're trying to get to. And now I oversee approximately 20 engineers and detailers combined between both my company, and we also have a partnering firm by the name of 2096, where we handle all types of steel structural engineering and various different manufacturing support.
So it is impressive to see how your hands-on fabrication experience has shaped your engineering career. The perspective has been incredibly valuable for you, I imagine. Now, your company focuses on designing and engineering welded steel structures for some of the most challenging industries like defense, mining, engineering, and even manufacturing. What role do you specifically play when a project is brought to you?
This really depends on the specific project. Ultimately depends on when our customers are really coming to us. We're not really that classical structural engineering company where our primary clients are necessarily architects. Since we focus on those fabricators, fabricators needs to truly get the job done. We really have to help them to get down to the nuts and the bolts. So sometimes this is like a turnkey package where somebody's coming to us, they just have a napkin sketch and they want us to provide everything from shop drawings, construction support. Other times we're brought in a little bit more of an urgent situation where, we're kind of coming to fill some gaps there at the end of the project, and, they ultimately need an engineer to help them get over. There may be some form of delegated design like these connections that they're coming to us for.
Now tell me why you chose to support these type of operations that inevitably must be stressful and chaotic.
Oh, I really think that, we want our customers to see us like a team member, not just necessarily some outsourced commodity. And so in order for us to do this, we have to really be there for them, really no matter what. Nowadays, we find more and more that, these fabricators are being forced to do things that they haven't commonly had to do. They're basically being delegated things like these connection designs where your EORs are kind of making them do the catch-all. So, we're now even seeing that this delegation is going on to our steel detailers, who are now coming to us with for these same kind of reasons. These detailers are identifying that, hey, there's a gap, and they need an engineer to come and seal off on the design so that this building can go together. So.
And when you think of your entire portfolio of work, what would you say the percentage is that focuses on connection design?
I mean, honestly, it's relatively low for us. currently. I mean, it's been more 5 to 10%, but these requests are actually increasing quite rapidly as kind of word gets around about what we're able to provide our customers. But much of this growth and success, I do contribute to us investing in these right tools, much like IDEA StatiCa, because these tools are really helping complement our skill sets and then showing our customers what we could do. So that connection design market is growing very quickly for us.
Then can you tell me a bit about the workflow associated with delegated connection design? Is it something that allows you to be part of a project from the onset?
I kind of wish it always would, but unfortunately, there's quite a bit of times we're kind of brought in at the very end of the game as the buzzer's going off. We find that commonly EORs are adding in those boilerplate statements to their designs that are a little bit of a catch-all for anything that may not be completed in detailings. Many of the times, this is something like any shear and moment connections not shown shall be the responsibility of the fabricator, or double angle shear connections are required throughout, and any deviation from these connections go onto the fabricator for them to ultimately design that deviation. This then makes it where, at that bid stage, they kind of just throw out a number, and then at the final stages of design, whenever you're getting into that approval, people like the steel detailers are coming in and saying, hey, we've got 10 connections that really haven't been detailed by the EOR fabricator. You're responsible for this. We need an engineer. So.
Now, when you're working on these types of projects, who do you get your inputs from?
It really depends on the client, honestly. Some are a little bit more prepared. They will, the project managers and the estimators actually will reach out to us. They've kind of been burned in the past, and so they realize, hey, we've got a couple $1,000s of engineering scope at the end of this. We need to make sure we get in front of this. And then, obviously, if I'm changing things at the end, that's a huge cost to them too. But there's then some of these other kind of more other fabricators that are kind of coming in at the end. Again, they just don't really know, so they're coming in, and it's going to end up being more the steel detailers that are kind of reaching out to us because the fabricators weren't completely aware of the requirements, and so those are the ones that are now coming to us to get them to help them through the gap. They can put a good design together, but ultimately you have to have that science behind it and the math that really proves that these connections work.
So it sounds like you're saying you're almost seeing a bit of a shift in the communication path from the fabricators to the detailers. So what do you think is causing that shift?
I mean, I've seen both sides of this coin. I've been a part of the teams and helped design buildings in the past as well. And so, I believe that these EORs ultimately they're being pushed to a permit set, and there's this mentality that you can just catch everything in the shops. So the fabricators really have nothing really to quote off of until that steel detailer starts digging into the model, and no one on the fabrication side really knows where the deviations are required from the EOR structural sets. So the detailers now are forced into that role again of designing these connections, but there are very clear stipulations about structural design components. You must be a PE in these states to approve these structural designs. This is then leading them to teams like mine, who is going to really work with their existing details and what the fabricator already really needs to hopefully minimize these changes. And when it comes to these complex moment connections, it can be difficult to create a cost-effective solution, especially if you don't really have the math and the tools behind you to say, yes, this definitively works.
So every project varies and every workflow varies. And it feels like there can be many ways that things can kind of get lost in the mix. So where do you see some data insufficiencies or traps in the workflow?
Personally, I think it kind of starts with the disconnect between architects and owners, just to put it more in the AEC world, and the EOR. So not everybody's really using the same systems and the same models. Some people have Revits and some people are using PDFs. I use SolidWorks, SDS2, whatever. Everybody's using these different tools, and the fabricators then come in. They have their own sets of tools, and they're saying, and so there's just this huge disconnect between the two. The only true thing that you really have are the PDF files or the drawings. But there's typically gaps created in that due to the boilerplate notes and the typical details. Now, granted, I understand why those are there, because you can't, a lot of times these EORs aren't necessarily contracted to design to that level of detail. But I don't know, maybe it's just like my millennial mindset. I started doing 3D modeling in 9th grade, and I'm just kind of wondering why we can't all have the same model. Why can't we all just really be talking from the same place? And I think that we would relieve a lot of our problems.
So I love your answer because I think you've just hit on a real core issue, right? The industry isn't at a single shared model yet. But at IDEA StatiCa, we strive to deliver tools that are moving us closer. Because it integrates with the major platforms, it allows teams to pull the relevant geometry and loading into one environment. It's really not about forcing everyone on the same software. It's about enabling smarter collaboration with the tools that you already have. So let's pivot a bit. You've recently completed an exciting industrial pipe rack project. Can you tell me about the project?
Yes. So I've kind of highlighted some of these complexities in connection design and disconnected teams, but truthfully, this opportunity specifically, the team really was almost flawless. I mean, the communication was there. They did need it fast though, and that's just kind of a part of the industry. It was needed fast, but the streamlined communication, the way that all parties work together really ended up helping this be a very streamlined project. The structure was designed by Hatch as the EOR. It was fabricated by a company called St. George Steel, a very loyal client of Weldment Designs. And then it was detailed by a steel detailing company called Cronus Steel Detailing, also a very close collaborator with Weldment Design. Together, this team, they really pulled off a pretty amazing feat where they've nearly completed almost 800 linear feet of fabricated pipe rack structures. And these are 28-foot tall, again, almost 800 linear feet of these for a magnet manufacturing plant that's in Oklahoma. So, in about mid-August, we were contacted by St. George Steel to support the detailing team with Cronus for the approval of these delegated connection designs. Hatch provided a very clear specification to follow that outlined both the moment and the shear requirements of each of these beams. We were awarded the contract that first week of September, so it was a pretty quick turnaround. And then within days, Cronus Steel, as detailer, provided us these updated erection drawings. But even more valuable, at least for us, they also gave us these IFC models. So we're able to take these drawings, we're able to take these models, and then from that, we're able to then analyze what they've already put together. Cronus had already worked with St. George Steel and made sure that this is what the fabricator really wanted. So we're really taking their ideas and then we're trying to prove it worked. Whenever we then kind of got together, we did identify those very critical details. We want to group as many of these things as possible, and then we began our analysis. About 2 weeks later, we were making some minor tweaks in the design based on our findings, and using IDEA StatiCa to help present that to the team. And then the following week, we were sealing drawings. So about 3-week turnaround for the full analysis of 4 different phases of these pipe rack designs.
It did move pretty quickly. Now, can you tell me more about the connection design itself for this project? What kind of challenges did you face?
So with this specific one, there was a lot of pretty tight spacing. The member sizes weren't very large. And because of that, it made it where we really had a little bit of an accessibility issue. St. George Steel wanted extended shear tabs, while the EOR kind of had a default of double angles. Double angles are much more conservative, reliable stance, while the extended shear tabs, they can induce some moments into these columns. So, by doing that, they had initial size of those shear tabs, and we were able to run the numbers. Luckily, we didn't find major changes, but whenever we dug into it, we did find, hey, actually your shear tabs need to be a little bit larger in these scenarios, and we needed repads on the back where these shear tabs were connecting to the webs due to the limit state that was ultimately governing that and wanting to kind of fail that web from that shear connection. But after that, though, we were able to pretty quickly explain that story. Cronus was able to update the details, and then we were able to provide the report. No comments on the report were received. They accepted it, but there was no rejections. It was all very clear and straightforward, and kind of a first pass try. So,
Right. And when you have all the pieces of the project completed, what kind of outputs are expected, and how do you share your analysis?
So, historically, we've done really more of just kind of a red line, and there would be quite a bit of back and forth. We've now got to the point where we will share our IDEA StatiCa models, every connection using the viewers that IDEA StatiCa has. And what's really nice about those viewers is that persons can then pull out the IFC models, they can pull out DWGs, really. Between the two of those, typically persons can then pull all the information they need. They can even dig in and find the weld sizing, so we can make sure that we are talking apples to apples. They can take that IFC model, drop it directly into their model, whether that be SDS or et cetera, and see the overlay, see if everything's matching up. So that's a good way of how we ultimately end up sharing that information. And then we'll also use just pictorials. We'll take our IDEA StatiCa model and we will show pictures of our results and ultimately help communicate that way. Seeing things in 3D, again, in my mind, is a little bit easier sometimes than trying to thumb through 10 different pages of details. So
I agree. The added of picture tells 1,000 words couldn't be more true. So you've talked a little bit about our reports and sharing the design diagrams or whatnot. How do you feel like IDEA StatiCa might be helping you to educate the industry and the people that you work with?
Well, the Shear tab example is kind of a prime one. So, you as an engineer, we do have to recognize who we're talking to. And I can't go to a fabricator and start talking about von Mises stresses and failure criterions. They're going to look at me like with their eyes crossed. So, but what's great about this is that everybody can tell what red and blue mean. Red fails, blue doesn't. And so I can very quickly show personnel that maybe don't have that engineering background that, hey, this is failing. You can see where it's failing. This is our weak point. How can we fix that? They can then come in and say, well, we've done it this way and we've done it that way. How about this? And then we can work back and forth together to get that good, effective solution. On the other end of the spectrum, when it comes to the engineers, though, you have reports that are sitting there producing actual calculations that tie back to AISC codes. So you can dig into these codes, you can validate it, you can learn from the codes as you're doing this, and I can tweak things. I can move this, see how the numbers move, and you can use that to help educate people as to learn a little bit more about these limit states and why these things are actually failing. So it really helps educate both sides of the spectrum.
So it is personally thrilling for me to hear you say this, right? You might be familiar with our tagline, calculate yesterday's estimates, which really reflects our mission to replace that guesswork with precision, right? Empowering engineers to make confident, code compliant decisions. And what you have just described is truly that mission playing out in real world. So thank you. And I welcome you to be honest. How has it been working with IDEA StatiCa?
I mean, the reason I came to IDEA StatiCa is because I typically get the weird ones, so to speak. It's not your common connections a lot of times. So I needed a tool that I could build almost anything that I wanted, and IDEA StatiCa really created that some bit of a limitless possibilities in this. Admittedly, the software isn't the easiest to learn, and I've used a lot of softwares, but at the same time, it really shouldn't be. This is a very advanced tool. There's a lot going on here, and this is a tool meant for engineers. So that learning curve's to be expected, and you really have to understand the science of this to really use it effectively. You have to be able to do these force balances. So that's probably the hardest part, but again, it's understandable from an engineering tool. The best part though is that when I get stuck, I'll call Andrea or John or Johan or any of them, and they will help me. They're basically on call from day one. So I've had abundant amount of support between them, and then you have all these educational resources too that really help educate me as well. There's a great page on limit states actually that y'all have created that I've studied and studied and studied. So overall, it's been a great experience.
Oh, that's wonderful to hear. Now, what recommendation would you make for someone who's looking to get into connection design?
Go back to the basics. So, in order to do this, you need to understand where these moments and these shears are coming from. You need to understand that force balance. You need to understand the equilibrium requirements of connection designs, and you need to understand the limit states. Why are these things failing? So, IDEA StatiCa can really help you, put a picture to this and help you run those numbers, but you really need to understand what IDEA StatiCa is doing and what it's proving. So, you're going to be pressured to make really big decisions, and a lot of times it's going to be that you have to do it really fast. So you really want those tools to be in place. You don't want to be trying to reinvent the wheel when you get that first PO. So make sure you have all of that. But, once you do, you will really gain respect for what this industry does day in and day out, and what we have to do to really make sure that the public stays safe.
Great, thank you. Corbin, I want to congratulate you on this project and your business growth, and thank you for joining us today.
Thank you for having me, Stephanie, and I look forward to our continued collaboration with IDEA StatiCa.
Absolutely. So at this time, we're going to pivot to my colleague, Andrea, who's going to walk us through the software and point out some of the IDEA StatiCa features that you yourself utilized in your pipe project. Andrea, take it away.
Awesome. Thank you, Stephanie and Corbin, for sharing your input. I just wanted to share 3 takeaways from this great interview. When you communicate the needed information, coordinate well with the other stakeholders, and you have the right tools, the structural engineering processes can be fast. I mean, 3 weeks, that is really quick in the engineering world. The second is that extended shear taps are a tricky but common connection in pipe rack design. Corbin was able to design and explain them using IDEA visual output. And the third is that Corbin used IDEA not only for complex but for simple connections too. All the connections from 800 feet of pipe racks just with one tool. All right, now let's jump into the technical demonstration where I'll show you how Corbin leveraged some of the IDEA capabilities to speed up his modeling process. This demo is divided in 3 sections. We'll talk about how to design custom gusset plates in IDEA StatiCa, how to share information with other stakeholders like fabricators or detailers, and finally, how to solve extended shear taps with IDEA StatiCa and all the options you have. Okay, let's talk about designing custom gusset plates. Corbin used the option to import the shape of a gusset plate from a CAD file for some of the horizontal bracing connections. We're going to look at the connection that you're looking into this slide. This joint seems to be complicated, but at the end of the day, they are just a combination of simple connections. And those can be modeled with the standard operations available in IDEA StatiCa. Here I have a summary of the 3 main operations that were used in this connection: gusset plate, clip angles, and stiffening plate. For those of you that haven't seen IDEA, let's go through the modeling and analysis process through the application. All right? So let's jump into the application now. So we're looking at the main IDEA StatiCa connection interface. Okay. So in this example, I already created the members. I already added all of them. In this interface, you will see the 3D model. You can rotate this model and then click on the different elements here. And once you click on them, you will see all the technical information in this side. All right. So you can look at the cross section that was selected for this member. Then you can also look at the different rotations of those members and offsets. This helps you to rotate members and move members from the working point. The working point can be seen in this view, which is the wireframe view, and that's where you're going to see the node, all right? So once you set up the members in IDEA StatiCa, then we can start looking at the connections. The way we model connections in IDEA StatiCa is through operations, right? So if we click over the new operation icon, you will see all the available operations we have. So here you can see some standard connections, and then we have other operations that will help you to create a more complex design, okay? In this case, I already have the operations model, so I'm going to show you how they work. So once you select what type of operation you want, they will be listed here. So I'm going to activate the clip 1. Let's look at the transparent mode. And you can see that the clip angle was added. In this operation, in this operation line, if you click on it, you will see all the properties of that operation. And that is basically selecting the clip angle, selecting the size of the weld, the type of weld, and then the bolts. In this case, we decided to put bolted connection to the column and then welded to the beam. Okay, so this is an example from one of the connections that Corbin designed. So basically, I'm going to show you all the operations that were used in this joint. Okay, after that, then we added a gusset plate operation. So let's activate that, and then that gusset plate operation is assigned to member M3. So all the operations are related to member. Okay, so depending on what member you select, then the connection is added. You can decide if it's bolted, welded. Everything is controlled from this operation. Okay. Once you have this gusset plates set up, one recommendation is that if you have a similar connection in the same model or in the same joint, you just can right click and copy this operation and reuse the properties of that operation. Like in this case, this gusset 2 is assigned to the bottom bracing. Okay, and you can reuse the information that you set up already on that operation. Then after that, instead of having just welded gusset plates to the members, Corbin decided to add clip angles from the gusset plate to the column. So you can add clip operations to gusset plates, like in this case. I'm going to activate clip 3 so you can see the third clip operation in this model. Finally, clip 4 is assigned for the beam coming into the web of the column, right? And now we're missing the horizontal gusset plate for this member. But in this case, Corbin wanted to use a specific shape in a specific shape for the gusset plate. Okay, so he had this shape in a drawing, so he drew that on a CAD file and then save it as a DXF. To be able to bring that shape into the software, you can use the stiffening plate operation. I'm going to activate this stiffening plate operation, and if you see in the transparent mode, that is set up here. This is the stiffening plate operation. And let me just click on it so it's highlighted. And then this is a rectangular shape and is set up at the center of this model, right? So you can change the shape of this stiffening plate operation to polygon. So I'm going to click over polygon, and then we can go to the DXF option, and then you select the DXF CAD file that you want to use to bring that shape. So I'm going to select that one, and then setting up the correct units for this drawing, select the shape, and then tell the software that this will be the outline. Okay, so I'm going to click OK here, and this is set up here in this side. As I said, I already put some properties on these operations, but you can use the X, Y, and Z coordinates to locate that plate, and then use the rotation angles to locate correctly where you need this plate. Okay, then to connect this plate to the main model, I can use a plate cut operation, and then that plate cut operation 1 is related to this SP1, and then that is cut by M2. You can see the properties in this area. Now I'm going to do the same for this side here. Now to relate this gusset plate or this stiffening plate operation to the member, I'm going to use a gusset operation. And this gusset operation, you can assign it to member M6, which is this horizontal bracing. And then you can select to connect this to an existing plate. So you can reuse one of the plates in this model to relate it to the M6 member, right? So that is how it works. So this is the overall process for modeling this connection. As you can see, here we have mainly clip operations, gusset operation, and stiffening plate operations, right? So basically standard operations to create a multi-member joint connection design. All right, so after you model the connections, you need to input the load effects into this model. The way we add load effects into this model is through the members. So basically you are adding the end reactions of all the members into this table, and then you can add axial, shear force, and moment forces on this joint, okay? So after you input these forces, you can add more load effects if you need that. You can just click over a new load effect here. But in this case, I'm just going to run one load case. So now we can click over the calculate button. Now it's running the FEA analysis and calculating the design formulas and getting results in the entire joint. So let's wait for the results. Right, after it finished, you will see a summary of results in this area, and then later you can go to the check tab and then review the results in detail, right? My recommendation for all the IDEA StatiCa users is to look at the form shape. To activate that, let's activate the equivalent stress, and now you can activate the form shape. And this is your first sanity check to see if this is behaving as you are expecting based on the forces you input in this model, right? So you can rotate this model and see the deformation to see if that makes sense. So here's where you can look at the load paths, the stresses, which is the plates are most stressed, and then decide based on those stresses. And finally, you can go through the different results like bolts, welds, and plates. Okay, so For plates and welds, for bolts and welds, you can click over the plus icon and then you can see the AISC design checks, and that's how we code check these elements in the connection. Okay, so everything looks okay on this connection. After this, we are going to create some deliverables, right? So if we go into the report area, here you have different options to create deliverables for other stakeholders. So in this case, I'm going to generate the detailed report, but you can also export this file to an IFC file, which is a 3D model. And that model can be, or that IFC model can be opened in another BIM application, okay? After I click generate, you can see the detailed report here. You'll get tables, you will get information of the model, you'll get stresses, the form shape, and all the information needed to review the calculation of this connection, right? And even some drawings for the plates. Also, you can export these drawings to DXF, so that is a CAD file if you want to deliver this to the 2D drawings. Okay, so that is basically the process of creating reports here in IDEA StatiCa. You can send that to a PDF or document, and finally you can create an online link to this model, right? That online link will create this 3D model in the IDEA StatiCa online viewer, okay? You can share this link to the detailer or the fabricator, then they can look at this model using this free viewer, and they can see information of this connection in this 3D model, and they can export this model to a 3D drawing file, they can export to an IFC file, and they can even export it to an IDEA StatiCa file, all right? So this is a way to share information with other stakeholders during this process, all right? Now let's go back to this presentation here. As I just show you, we can create PDFs, document reports, online free viewer links, 2D CAD drawings, and then IFC files for delivering this information. So as you probably know, the output of delegated connection design is as important as the design process itself, right? Because you are sharing final construction details to fabricators. So in this case, the data exchange is key. IDEA help Corbin in different ways to achieve this transfer of information. Okay, now let's jump into the third part of this presentation. Now let's talk about extended shear plates. Shear plates are one of the most common connections as they are easy, quick, and economical to construct. However, when geometry is tricky, sometimes these plates need to be extended. And because of that, the extension, some moments are induced into the support element, so they need special attention. In the AISC code, the extended shear plates have a procedure to design them specifically for this case. As Corbin mentioned, in IDEA, you can design these special cases and see the deform shape and load paths to make informed decisions like adding stiffeners, what will be the thickness of it, and then weld size, etc. But the most important part is that you can agree with the fabricator based on results and show them the behavior that will justify your recommendation. All right. I also wanted to share this verification study that we did for extended configurations in IDEA StatiCa versus traditional hand calculation and design. You can see this verification study using this link for more information. Okay, so let's take a look at the mini study I performed for two types of extended shear plates. The first one is a beam-to-beam example. In this slide, you will see the model and then the stress and the form shape of the different cases I studied, all right? So you can see in the first option that is a beam-to-beam connection extended shear tab and with any stiffener. Option B has a stiffener in just one side, as you can see here. Then the option C, it has a doubler plate at the beam web, so that is a welded plate on the web of the support beam. And option D is a shear plate that is working as an stiffener because it's welded all around the supported beam. In all the models, I applied the same load, okay? But they have different stiffener configuration. So from this study, in general, you can see that from the deformed shape, that the last option D is better than the others, right? And it has lower stresses on the extended shear plate. However, if we look at the plastic strain for the plates in this summary of results, the lowest plastic strain on these models is option B. Okay, so you can compare different things from these studies, right? But the most important is to show this result and make decisions based on data, right? Let's review the next example. So now I study or I model a beam to column web extended shear plate with different configurations. Again, option A, no stiffener. B, column web doubler. Option C, column stiffeners aligned to the shear plate. So you can see here, they are aligned to this shear plate. Then finally, option D, shear plate welded to the stiffeners on this side of the column. So from these results, from the summary of results and then the form shape, the most efficient design is the shear plate welded all around the stiffeners. In both cases, we got kind of similar results, and this can be an obvious design. But what about constructability? Is this an efficient design to construct on site? Well, that will be something you can consult with your team and make decisions based on this type of information. However, this type of study took me less than an hour to test different solutions. So you can do quick designs and test them and then use this information to make faster decisions on site, right? I even spent more time taking these screenshots and paste them here in the slide. But anyway, the intention of this study is to show you how you can model different options and then see the results and use it for their design. All right. So this is all I have for this technical demonstration. We look at these three different portions of the demo. But again, if you want to see a tailored demo, reach out and we can help you to show you how IDEA StatiCa can help for your next projects. Okay, so now let's jump into the final part of the webinar.
Great, thank you so much. Now we hope this walkthrough of a real world project gave you more than just theory. Our goal was to show the mindset behind high quality industrial design. And this is just one real life example, but we are curious, what type of projects are crossing your desk the most? So we're going to go ahead and launch another poll. And if you don't see the type of project listed here, we invite you to enter it into the chat. Thank everyone that participated in that poll. Your answers here will be used to inspire us here at IDEA StatiCa for designing future content. Now, thank you everyone that has submitted questions through today's presentation. As a reminder, you can enter questions in the GoToWebinar question panel. Now, my colleague Andrea has been going through and answering as we went, but let's go through a few together. Andrea, can you walk us through a few questions that might be interesting for the audience?
Yeah. I have some of them here, Stephanie and Corbin. Are you there for some questions that we have from the audience?
Yes.
Are you ready? So yeah, so we have some questions for you. And I believe they're kind of interesting regarding your interview that you had. So one of them is, has Weldment design have been involved in connection design during the design contractual phase? So she's saying like, assume you will be brought on a sub-consultant to do design of connection. Have you had that experience, Corbin?
Being brought on as a sub consultant, as in just like I mean, yeah, I think that's a common delegated design approach of being brought on as, I believe I'm understanding that correctly.
Yeah, and then well, one part of this question is, what type of quality assurance checks are done?
As far as in our internal process?
Yeah, yep.
So we ensure that we always have a QA buddy. So there's typically 3 personnel that are involved in our designs. We have the engineer or even a designer that potentially is doing the initial model and the analysis. We'll then have a QA buddy that is working to to check the work, make sure everything's complete, and then you then have the EOR, the person who is ultimately sealing that as well, that creates that third level of check. So those are our how we ensure that quality. As far as our internal checks, we also have data communication logs and ensuring proper document control in our quality as well. So every transmittal, every document that is either received or sent is very clearly logged in our system, when it was received, what it was, and then typically a record as well of who sent it to. So
Right. Then there is one interesting for you as well. So it says, please share your thoughts on how strengthen communication and accountability between EORs, connection engineers, and fabricators to reduce work and keep projects on track. I mean,
I'm kind of amazed how often we don't fully know who the players are. You might know that who the engineering firm is, or maybe the contractor, but you don't really have a core team that is established. What I end up doing a lot of times, if I don't end up knowing who these EORs are, I pick up the phone and I end up giving them a call, and making sure that they know who I am. It helps when we are all recognizing we're all persons, and I think that would really help improve it by recognizing that everybody's a team and actually outlining who that team is. All of a sudden, walls begin to get broken down whenever we do that.
Yeah. Again, that's a good thought there, or like recommendation, let's say. So I have here for you about like the use of extended shear plates versus non-extended shear plates. Do you have a preference? Is that on you, or do you kind of ask EOR or the fabricator on deciding what to use? What is the best?
So I mean, we're typically doing what our fabricator wants to do. If they're kind of going through a redesign, they're absorbing costs for a reason on this. Now, granted, they're doing that because it should be saving them time in the long run. These extended shear tabs, they're great for accessibility, and it likely drastically improves their ability to assemble, and could cost you a lot if these are not perfectly aligning. So yeah, I think would be the gist.
All right, and then the last one that I have for you, if you can say one benefit and one maybe risk of delegated connection design in this type of structure, and what every stakeholder should understand, if you have kind of an input.
Sorry, can you repeat the question?
Yeah, so it's what are the benefits and risk of delegated connection design? I mean, I'm just asking if you have one benefit and risk that you can share with the audience. Yeah.
Yeah, I mean, the benefit of it is, I mean, you get to complete the project, you get to put the nuts and bolts into this, you get to be the one that really is finalizing this for that permit set, and really supporting your team. I think there's a lot of benefit in that. I think from an educational standpoint, it's good to truly be able to tie that bow, to truly understand all of the nuts and bolts and the pieces of it. That's very much beneficial. Now, the downside of it is really with any level of professional engineering is we have liability in what we do. People's lives are at stake in this. So, that's a scary thing, and it's intended to be. We have a lot of responsibility that we hold here. So, don't take that lightly. So.
Yeah. Right. Well, thank you. There are some others like related to IDEA StatiCa that I can take on. Let me see here. Yeah, there are questions about like the position of the force, if it's on bolts or nodes. This is kind of one of the boundary conditions of IDEA StatiCa. So in a recent webinar that I did, I have this rule of thumb. If the member has only shear force, then this is when it's important. So if it only has this shear force, then you need to specify the software where you want that shear force acting. That's why we have this option to shift the force along the member, either in a position, so you can tell from the node and at what position you want that shear force acting, or if you select bolts, it will detect if there is any bolt, and that will locate the shear force at that position. But it's really helpful to go to the software and then click over the member, look at the transparent mode, and you will see the moment diagram. And where you have 0 moment, that's where the force is located. Okay, but I'll follow up with the person who asked this, and I'm going to send some information. All our technical information is in the website, so we have this type of information there. Yeah, and there is a question here. In the first example of the pipe rack connection, it appeared the column web was exceeding the 45 psi threshold. Did I miss something there, or does the program not check the column web? So the software will check all the plates that are in that model. So it's running an FEA, and then we are looking at the material properties, and then it will check all of them. If you go to the check tab, you can see the plates tab, and then you will see the list of plates there. So in that case, for the web, probably it was at the elastic limit. It has kind of this, it was red, but it wasn't failing. It was just only the stress on that plate. And we allow that material to go into the plastic area a little bit, and that's why it wasn't highlighting as failing, but it was kind of in a high utilization ratio for that. So that's that. And then I saw another one here. Those IDEA StatiCa have training courses for learning the software and have examples from real projects. So yes and no. So we have trainings for courses, but I mean, if you want kind of a real example, we have some examples, right? But we don't have kind of a real project where we can take one example, because they are maybe from other users. So if you want a specific example, you can bring this example to us, and we can help you to understand how it works in IDEA StatiCa, but from your example, right? So we can use one of your projects to show you how to use IDEA StatiCa. There are other two here. So probably this is for you, Corbin. There is another one for you. How do you approach projects in which the EOR has left out a lot of the needed information you need? What has been most efficient to get answers? RFIs, phone calls, maybe emails?
I mean, depends on the person. I always like to try to have a phone call initially and then follow that up with a more formal RFI. But sometimes the communication's not there, and RFI becomes your only main option. So, but there have been quite a few instances where you have to ask. I had a situation recently where they said that the connection must transfer the full plastic moments, and as soon as you did that, it made the columns fail, and that obviously wasn't what their analysis showed and what was really occurring. So I had to reach out, ask an RFI for the actual design loads, and when doing that saw a drastic reduction from plastic. So
Yeah. All right. Well, I'm not sure if we have an extra slide, Stephanie, there, or
We do.
that
Thank you for
all?
walking us through those questions. So thank you so much for joining us today and for being a part of the conversation. And a special thanks to Corbin for sharing one of his projects with us. In today's example, if this sparked ideas or if you see opportunities to improve your own workflows, whether that be speeding up connection design or unifying your engineering and details communications, we'd love to continue this conversation. You can get in touch through email, join the discussion by connecting with us on LinkedIn, or explore some of the features you saw today with your own free trial. We're looking forward to great things ahead in 2026 and to seeing you in the next webinar in the coming year. Bye for now, and thank you for joining.
thank you.
Thank you, Corbin. Bye-bye.